Come on, man. Okay, morning class. Hopefully you all are ready. Soon we will start. So yeah, for those in YouTube, you can start commenting. Good morning. Okay, for those who are here already, hopefully we will start soon. So yeah, soon we will start. Please be ready. Okay, I'm trying to share a screen. Hopefully I will be able to share the screen soon. So yeah. Okay, I can't be able to share the screen right now. Not sure why. Hopefully I can share soon with you all. Okay, those in YouTube, you can type your message there. So soon I will be able to see you all. Okay, and please do invite your friends lah, eh? For those who are ready. Very good, Fatin. Okay, Alia, okay, Aisha. Okay, hopefully all of y'all can see the screen right now. And that's clear for all of y'all lah. Okay, that's clear for everyone. Well, today I'm in college, so yeah, maybe a little bit slow, the internet. Hopefully all understand. Okay, I can see that you can see the screen. Hope everybody can be able to see the screen. Huh? No problem. Huh? Can you all see the screen or not? The one in YouTube can see the screen? Yes or no? Are you all seeing anything? Maybe I stop my share again and reshare again. Hopefully you all can see the screen soon. Okay, I hope now you all can see the screen. The one in YouTube, now you all can see, right, the screen? Yes, sir. Okay, I hope that's big enough and you all can see live. Okay, that's good. Okay, I can see that some of you all replied me back, yes. So, yep, good. Okay, so our topic today is going to be polynomials. So, please be ready. Lah. Okay, please be ready. I hope those in YouTube can even hear me. Okay, and those in Zoom, I hope that you all can see the screen also and you all will be ready. Waiting. Okay, the others still waiting for your response. So, yeah, while you wait for your friends to come in, here a small video for all of y'all. Hopefully, y'all can enjoy this first. Okay, welcome to the class, and in a while we will start. So I hope that everybody can be ready and we can start soon lah. Okay, we can start soon. Okay, we will start with chapter 6 today, polynomials. So hopefully everybody is ready lah. Still waiting for others to join, then I can start. Okay, sharp 10 o'clock I will start live. Okay, sharp 10 o'clock I will start. So, yep. Okay, good morning, Ain. I hope all the other friends of yours are here already. Okay, I can see most of you all already enter. So yang dah masuk itu bagus. Yang belum itu, I hope that you all can be ready lah. Okay. Okay, please mute yourself up. For those who are in Zoom, please mute yourself so that we will be able to begin in a while. And for those who are in YouTube, hopefully you all are ready. Okay, still got 1 more minute before I start. I still don't have many of you all in the class yet, so yep, I'm still waiting. Hopefully I will be able to get as many as you all get lah. Clear? As many as you all are here. Okay. Okay, morning Chu, morning Izul. Okay, morning Nur Atika, morning Lukman, morning Akil, morning Nur Saiza. Okay, I can see that there are 40 of you all here and 24 of you all there. So, yep. Okay, morning. Okay, morning Kiranya. Okay. Okay. So, yep, I'm going to start soon. Hopefully, we can start soon. There's only 64 of you all here. I'm supposed to get more than 100. So, yep, I'm still waiting. At least I should get around 90 plus lah. Then I'll be very happy and to start the class. Okay, when you all don't join the class later when exam, it's very, very hard for you all to do. Okay. So, yep. So let's start lah. Okay, let's start. Here you go. Let me show the countdown. Okay, let's start now. Okay, we got 87 of y'all here today. So hopefully everybody will be ready to study lah. Okay, so yeah. Well, for those in Zoom, I hope that you all can respond back lah. Okay, and those in YouTube, you all can see the screen clearly, and should be okay for all of you all to view the screen nicely lah. Okay, so let's see here. Okay, we go to polynomial first, the first chapter of uh, the chapter 6 there. Okay, under first chapter of chapter 6 over here, you can see one thing that what we are going to do here is basically going to be what is this called? What we are going to study here is perform addition and subtraction of a polynomial function, and then on top of that, we are going to carry on of perform of division of polynomial. So what is polynomial actually lah? Okay, polynomial was actually introduced to you all in school itself. Okay, where you see a constant function. Constant function is a polynomial. Okay, a constant function is a polynomial. Then we have a linear function, which is also a polynomial function. And then we have quadratic function and then cubic function over there. So all these functions here are called polynomial. I hope I'm not lagging and all of y'all can hear me clearly. Everybody can hear clearly, yeah? No problem, huh? Okay, very good then. Okay, now all these functions are special cases of the general class of function called polynomial function. So we also have a quartic function. Quartic means power of 4. And then we have power of 5, power of 6, and all the way until power of 100 lah. Okay. I see the Zoom. I hope everybody still can see the screen. Huh? No problem, right? Okay. Huh? Okay. Okay then. Yeah. Hold on. Just give me a second. My screen sharing is stopped. Yeah. Let me reshare the screen again. Hold on. I have no idea why this problem occurred today. But yep. I'm in college today, so yep. It's supposed to occur anyway. Yeah. I'm not sharing anything, so hold on for a while. Okay, I'm trying to share the screen. Yes, okay, now I can share. This is better, I guess. Uh-huh. Now you'll be able to see your screen better. Yeah. Now this will be great for all of us. Okay, and those in Zoom, let me stop the share and share again. Share screen, window, and render, and I share. Okay, those in Zoom also, now you all should be able to see the screen in a while. Lah. Okay, you all will be able to see the screen in a while. Can right? Everybody can see the screen right now?
Yes, sir.
Okay, good then. Now this is smoother. Okay, now let's carry on. Okay, let's carry on. Like that. Okay, so here, now we go back. Now all these polynomial functions already you all learn already and you all know already a little bit. So now we come to the basic stuff, which is called the addition and subtraction of polynomial. So any addition and subtraction of any polynomial only can take place when basically we have two powers which are the same, or the degree of the x or the degree of the polynomial is the same. Then we can plus and add lah. Okay, so for example over here, if I give you px is 2x power of 4 minus 5x cubed minus 4, and qx is x power 4 plus x cubed plus 3x squared plus 4x, then you can add these two polynomial, and you can minus these two polynomial. How to add them? Or 2x power 4 and x power 4, you add them. Power of 3 and power of 3, you can add them, and negative 4 with negative 4 means 0 over here lah. Understand? So x cubed with x cubed, x power 4 with x power 4, x squared with x squared, and that's how you add them. Okay, so from there you get this basic function here. So I think this one I don't need to explain so much because this is basic stuff over here. Okay, and then we have multiplication. Multiplication also, we just take 4qx there. 4qx means 4 times a polynomial. So 4 times 2x cubed minus x squared plus 1. Straight away you get that 8x cubed minus 4x squared plus 4 there. And px times qx, okay, you times the polynomial. So you do your multiplication. Everybody know how to do this, right? Okay, and this one. So since all of y'all can expand that, I'm very sure you will be able to get the final answer over there. Just remember that x squared times with 2x cubed, that will give me 2x power of 5 because power of 3 must plus with power of 2 there. Okay, so that's what you have to know lah. Okay, now they say if px is a polynomial of degree m and qx is a polynomial of degree n, then the product of pqx must become degree of m plus n. The product of pqx must become the degree of m plus n because that will be the highest power lah. Okay, now I can tell you here power polynomial px is degree 2, qx here is degree 3, so 2 times 2 plus 3 there. Okay, 2 plus 3 will become power of 5, so pqx is power of 5. Can see that also lah. So I hope that is clear for everybody over there. Okay. Okay, now we go to the next one there. This is the most important thing or important part of this chapter, which is called division. Okay, under division over here, under polynomial, we can divide the polynomial like how we divide any fractions. Okay, for example here, 11 divided by 2. This is going to be 5. Okay, means you're going to divide like this, right? Not? If you don't believe, you're going to do like this, 11 divided by 2. So the quotient would be 5 here. Here you get 10 and the remainder is 1. So what you wrote down here is basically, okay, 11 here is your polynomial, px. So px equals to, what you're going to get here is like this. The quotient, qx, times by the divisor, dx. So this is qx. And this is the divisor, dx. Plus with the remainder rx. This is your remainder rx. Okay, that's how basically you get 11 there. Don't believe px is 11 equals to 5 times 2 plus with 1 remainder. That's how I get 11 over there. Can see that? So this is a formula which we have to be able to see. Okay, which is actually we know already. Okay, which is we are getting since day one. Just that you never been exposed to this formula. Okay, you are never been exposed to this formula there. Okay, so this is polynomial formula here. Remember, polynomial equals to dx qx plus rx over there. Okay, now let's say if I give you one example over here, you can tell me, okay, x squared, okay, x squared plus 2x minus 5 divided by x. Of course, the divisor must be lesser degree or equal degree to the polynomial. The divisor over here, dx, must be, the degree must be lesser or equal to the polynomial. So here you can tell me the polynomial degree is power of 2. Okay, so the divisor degree over here, the divisor degree is 1. Can see that? So it's lesser lah. So from here, how to get x squared? X times x will give me x squared. Okay, so you put a minus sign here, 0. So x squared minus x squared become 0 already. So left only the balance is 2x minus 5. Bring down. So once you get the 2x minus 5 ready now you know that how to get 2x or positive 2 lah. Positive 2. Positive 2 times 2x, where positive 2 times x will give you 2x, so minus. So now will become negative 5. So negative 5 is already lower than the divisor. This is a constant. Okay, this polynomial is a constant over here. This is power of 1. So since the degree is lower than the divisor, we stop. Since the degree is lower than the divisor, we stop lah. Okay, it have to be lower. It cannot be equal lah. It have to be lower. it have to be lower. Okay, here also the same thing. If you divide like this, you see remainder is 1. 1 is lower than the divisor, which is 2. Then we stop, right or not? So the same thing we apply back over here. Lah. Once the thing is lower, we stop. Okay, so we already get the remainder. So now if I want to write the polynomial, px equals to x plus 2 times by x minus with 5. Okay, how I get that? Oh, this is my qx, this is my dx plus with rx. So if you don't believe you can expand out this thing, you're going to get x squared plus 2x minus 5. Isn't this the same thing as our polynomial, original polynomial over there? That's the right thing. No? Can you all understand until here so far? Everybody clear until here?
Clear, sir.
Okay, if clear, I show one more. Okay, I show a little bit more interesting one. Let's see here, 2x squared plus 3x minus 6 divided by x plus 1. Okay, so I do here 2x squared plus 3x minus 6 divided by x plus 1. Let's change the color to make it more fun. Okay, how to get 2x squared? Yes, anybody can tell me how to get 2x squared? What times x plus 1 will give you 2x squared? Come on. 2? Yes, 2x. That's right. Okay, what times 2x? X plus 1 will give you 2x squared. 2x there. Lah. Clear? 2x will give you 2x squared there. Yes or not? So 2x squared here plus with 2x. 2x times with x plus 1 there. Correct. Very good. Okay, those in Nurul Aziti, Ahmad Rafiq, Ain, Nur Swaiza, excellent. Very good. Okay, so you all managed to get the answer there. So now from here, I put a minus sign here. Remember, we always put a minus sign out here. So 2x squared minus 2x squared will cancel. The first term will definitely cancel off. 3x minus 2x will give you x minus 6. Now, what will give you x minus 6? Oh, x minus 6 is plus 1 only. What will give you x lah, basically? So x is going to give me by plus 1 only. So x minus 6 over here. So put the minus sign here. Negative 0 there. So basically, sorry, x plus 1. My mistake. X plus 1. So negative 6 minus 1, you get negative 7. And this is already a constant. See, this is power of 1. This is power of 2. The divisor and the the polynomial can be the same power, but the remainder have to be lesser. Understand? The remainder have to be lesser. So this method is called long division. Okay, this method is called long division. So if you want to write back again, no problem. You can tell me the polynomial x equals to 2x plus 1 times by x plus 1 minus 7. How? This one times this one plus back by this. That's all. Okay, very simple as that. Okay, now I can tell you determine the remainder. Okay, I can tell you to determine the remainder by long division of this thing. So let's take here 3x cubed minus 4x squared plus x plus 7. I want to determine the remainder, so divide by 3x minus 4. Okay, I can ask you to determine the remainder and the quotient lah. Okay, so I can do this thing here. So I know that to get 3x cubed, I have to put I must put here x squared only. Okay, so times I get 3x cubed, okay, minus 4x squared. Put a minus sign there. Oh, exactly the same, so it becomes 0 straight away. So all this will become 0, left only x plus 7. Okay, x plus 7 there. Now how to get x plus 7? Oh, x plus 7 there, you can times this by plus with 1 over 3. Okay, you times this by 1 over 3. So you're going to get x minus 4 over 3 there. So 7 minus 4 over 3, that becomes 7 4 over 3, which is basically going to be 8 1 over 3. No? Understand? 8 1 over 3. That is the remainder over there. So I think that is very, very obvious. Okay, unless I did any mistake. I hope no. Put plus. Yes. Okay. So here, now this thing here, if you look this they put negative 2x plus 11 also can. Why? Because this thing here is lesser than 3x minus 4 also lah. Okay, but I don't prefer this way. Okay, I don't prefer this way. Okay, now let's see the next one there. Okay, let's see the next one here. I want to show you something. I can also determine the remainder by using this. Px equals to 3x cubed minus 4x squared plus x plus 7. So if I want to determine the remainder, I can tell you 3x minus 4 equals to 0, x equals to 4 over 3. So if x equals to 4 over 3, 3 times 4 over 3 power of 3 minus 4 over 3 square plus 4 over 3 plus 7. I'm very sure if you calculate this, you're going to get 8 1 over 3. Okay, I'm very sure if you calculate this, you are going to get 8 1 over 3. Then. Don't believe, you can go and calculate. Guarantee you will get 8 1 over 3. That's why I say this is better. Lah. Understand? This is better over there. Okay, let's move on. Now, once we know this already, okay, we have to go on some more. What we have, the next one here is, this is okay. Okay, I can try to show you this first. X cubed plus 2 there, x cubed minus 1 here. Okay, divide by x plus 2. So if divide by x plus 2 here, here is going to become x squared. So x cubed minus plus 2x squared. Put a minus sign. Oh, 0 minus 2x squared. So negative 2x squared minus 1. That is the remainder. Because here have no x squared. If no x squared means 0 minus x 2x squared, which you get negative 2x squared. So now from there, how to get negative 2x squared? Minus 2x. Lah. Negative 2x times x will become minus 2x squared. So minus 2x squared minus 4x. Put a minus sign there. So you're going to get 4x minus 1. So now plus 4. You're going to get 4x plus 8 there. Minus. So here you get minus 9. You can see that. Okay, so your remainder is negative 9. Now let's see if I want to determine the remainder with a faster method. I can write down px equals to x cubed minus 1. Okay, I know that the divisor is x plus 2 equals to 0, x equals to negative 2. Substitute the negative 2 inside here. So p negative 2 is negative 2 cubed minus 1, negative 8 minus 1, which is negative 9. Understand until here so far? Can? Okay, so what is this called? Or what is this part here called right now? This is called the remainder theorem. This part over here will be called the remainder theorem. So after this, I will show you how actually we see remainder theorem. Lah. Okay, now when we use long division, basically to get the remainder, okay, remainder and also the quotient. This quotient, for me to get this quotient, I have no choice but to use long division. Lah. Okay, when they say find the quotient and the remainder, to get the remainder, I can still use remainder theorem. But to get the quotient, I have no choice but to use long division. Okay, so that's what they mean by using the long division to find the quotient over there. Okay, now there are a few examples over here, so you can go and try it by yourself. I will like to take attention for this example over here, the last one which I do together with you all. Okay, x power of 4 plus x cubed. Okay, here have no 0x squared plus x plus 6. Some people like to put 0x squared, can lah. Don't want to put also, no problem. Okay, divide by, here expand this thing first. So x squared plus 4x plus 3. Now what times what will give you x power 4? Okay, x squared, very obvious. So x power 4 plus 4x cubed plus with 3x squared. Put the minus sign there. X power 4 will cancel off. 1 minus 4 will become negative 3x cubed minus 3x squared, because 0 minus 3x squared plus x plus 6. That is the balance there. How to get negative 3x squared? Negative 3x. So negative 3x squared, negative 3x cubed minus 12x squared plus with, minus with 9x. And then plus 6 there, so no need. Okay, put minus there, so cancel. So here you're going to get 9x squared and then plus 10x. Remember, negative 3 minus become plus 12. So negative 3 plus 12 will become 9. Lah. Okay, and then 1 minus become plus 9. So 1 plus 9 becomes 10 there. Okay, plus with 6 over here. So how to get the balance here? Plus 9 here. So 9x squared plus 36x plus 27 minus here. So from here you can get 10 minus 36 over there, which is going to be negative 26x 6 minus 27, then negative 21. Now look over here. This is already a linear equation. This is linear, this is quadratic. So cannot do anything much already. You have to stop here. Okay, here is linear, here is quadratic. So have to stop here. One is power of 1, this is power of 2. So have to stop already. Clear until here? Okay, so what is the quotient over here? The quotient is this now. Okay, the quotient is this, and the remainder is negative 2x minus 21. The divisor is this now. Okay, the divisor is this. Okay, so I hope until here everybody okay. Any problem until here so far? Okay, now again, I don't like to write like this. I prefer writing like this: x squared minus 3x plus 9 times by the divisor x squared or x plus 1, x plus 3 plus with negative 26x minus 21. Always write down your quotient times by your divisor plus with your remainder. Understand? Plus with your remainder. I hope this is clear for everybody. Any problem until here so far? Any problem until here so far? Okay, everybody. I hope everybody clear. Anybody got any question until here so far, class? If you have question, please do ask. No, no comment.
No, sir.
Okay, very good. So if no, then I move on lah. Okay, if no question, I move on. Okay, so the balance questions there, you all can look by yourself and you all can go and try by yourself. There are a few questions here for you all to try. Okay, now we go to the next one, which is called the remainder theorem. Okay, remainder theorem and factor theorem. If you understand remainder theorem, you will understand what is factor theorem, and then you straight away get what is zeros lah. Okay. So let's see what the polynomial looks like. A polynomial formula is px, qx, okay, qx, then dx, okay, plus with rx. Okay, you agree with this, right? Okay, now if I write down here, you can tell me here, this is 2x squared plus 3x plus 9, and the divisor was x minus 2, plus with the rx, px. So if I want to find the remainder, only, I have to make either this become 0 or either x minus 2 becomes 0. So either the green color part becomes 0 or either the blue color part becomes 0. Either the quotient becomes 0 or the divisor. Now quotient cannot become 0. Quotient cannot be 0. So the only thing which can become 0 is the divisor. How to make it 0? Oh, I substitute 2 inside here. Yes or not? How did I get 2? Okay, x minus 2 equals to 0, x equals to 2. So if I write down P2, okay, here you can go and substitute the 2 inside, no problem. Okay, but no use because this will become 2 minus 2. 2 minus 2 is going to be 0. Plus with R2. So this whole thing becomes 0 already. 0 times this thing, the whole thing here will become 0. So whatever we highlight in blue now becomes 0 already. So here becomes 0 plus R2. So by just putting P2, I get the remainder of the polynomial, okay, of polynomial px at x equals to 2. Okay, or remainder when divided by x minus 2. Understand that? Okay, so that's what our main idea is lah. Okay, so if I look at the remainder theorem tells me to get PA, okay, PA equals to the remainder of A there. Okay, why did you substitute 2 in px? Because I want to get, if I substitute 2 inside all these x here, of course here must be x, right? 2, right? That's why. Understand? That's why I substitute 2 inside the px. Fairuza asked me, why did I substitute 2 into the px there? Okay, the reason is because if I want to get, if I put 2 inside here, all these must become 2, right? Not? Okay, so if I put 2 inside the remainder, 2 here, all this x becomes 2 and here become 2 minus 2, which is 0. So since this becomes 0, so I straight away get the R2, which is the remainder of the polynomial when x equals to 2. Clear with this, Fairuza? Okay, I hope that is clear. Okay, so I move on. So the remainder theorem tells you that if PA equals to RA, that's all. That is what the remainder theorem is telling you. PA equals to RA. P3 equals to R3. P4 equals to R4. And how to get the A? The A is basically by X minus A. We get from the divisor. Okay, which X minus A equals to 0, X equals to A. So that's how I get the A there. I hope that is clear for everybody. Okay, so let's see here. We see one question here. The remainder of X plus 3. So I know that X plus 3 equals to 0, X equals to negative 3. So I know P negative 3 is going to give me, okay, the remainder straight away. Negative 3 power of 4 plus with negative 3 power of 3 minus with 2 negative 3 square plus with 4 negative 3 minus 5. Get the answer straight away, 19 over there. Can you understand until here so far? Okay. I hope everybody clear lah with this. Any problem until here? Okay, so straight away we get the answer. And if I give you 3x minus 1, no problem. 3x minus 1 equals to 0. So x equals to 1 over 3. Substitute 1 over 3 inside all the x values there. From there, you get the remainder already. Okay, from there, you get the remainder already. Let's look at this question here. Okay, we look at this question here a little bit. They say that when this is a polynomial, is divided by x plus 2, the remainder is 16. So P negative 2 must equals to 16. So I know if I substitute negative 2 inside here, negative 2 power of 4 plus with k negative 2 power of 3 plus with 5 negative 2 square minus 6 negative 2 minus 8 equals to 16. So 16 minus 8k, okay, plus with 20 plus with 12 minus 8 equals to 16. So negative 8k, 32 plus 16 over there is going to become 48 minus 8 there is going to become 40. Yes or not? So you shift over will become negative 24. K will become 3 over there. That's it done. I hope this is clear. Okay. I hope this is clear for everybody over there. Any problem until here so far? Can? Because Hatta asked why use remainder theorem instead of long division to find remainder. Faster, Hatta. You can use long division. I never stop you, but faster lah to use remainder theorem. Clear? And you look at this question over here, you cannot be using long division anymore. Understand that? Okay, why you cannot use long division? You don't know what is k. So how you want to use? Okay, so remainder theorem will help you solve the problem there lah. Clear with that, Hatta? Okay, remainder theorem will help you solve the problem over there. Okay, yeah, short work. Very good. Very, very short. Easy. Okay, very short work and very easy. Okay, very good. Okay, let's move on some more. Okay, let's say over here, the polynomial ax power of 4 minus 5x cubed plus bx squared plus 7 minus 7x plus 1 and left a remainder negative 8 when divided by x minus 1. So you know P1 equals to negative 8 lah. Okay, you know P1 equals to negative 8 and you also know P negative half equals to 11 over 2. So if I know this already, I write down like this first line. Okay, write down like this. You know the divisor, right? Not the divisor over here is x minus 1. The divisor for this is 2x plus 1. So of course, get x minus 1 equals to 0, x equals to 1. Then you get P1 now. Here 2x plus 1 equals to 0, x equals to negative half. Then I get P negative half then. Okay, so if I get P1 equals to P1 equals to negative 8 already, I can substitute 1 inside all this equation here. I'm going to get this equation here. A minus 5 plus B minus 7 plus 1 equals to negative 8 there. And then if I put negative half inside, I'm going to get another one more equation here. So I already get two equations over there. After I get the two equations over there, of course, what can we do right now? We can solve this problem by, what is this called? Solve the problem by simultaneous equation. Clear? We can solve the problem by simultaneous equation. I hope that is clear for everybody. Any problem until here so far? Any problem until here so far? Okay, very good. Okay, then solve simultaneously. We already get A and B there. Okay, we get A and B there. Any question answer remainder theorem? Any question inside remainder theorem? Okay, no question. Okay, I hope everybody is clear this line. Okay, so now let's look the next part here. Now, once we know what is remainder theorem already, okay, let me just go to the next theorem, which is called the factor theorem. Okay, this is just examples. So, yep. The next theorem here is more interesting, which is called the factor theorem. Now, under the factor theorem, okay, it's the same as remainder theorem. But let's just look over here. If I give you a polynomial, x squared minus 5x plus 6, okay, I know that these factors over here is x minus 3 and x minus 2. I know these are the factors, okay? Or I know this one can divide by x minus 3 and can divide by x minus 2. So if I get P3, I want to find out what is the remainder. The remainder for this is going to be 0. And I also get P2, the remainder is going to be 0. So factor theorem is just telling you that the remainder is 0. That's all. If the remainder is 0, then x minus a is a factor. If the remainder is 0, then x minus a is a factor. That's all. Clear until that? So if it's a factor, therefore the remainder must equals to 0. So let's see over here lah. Okay. That if I give you this, to determine that this is a factor or not, first thing I get P3. I substitute 3 minus 7 times 3 plus with 5 times 3 square, okay, minus 3 cube over here. So from here I get 3 minus 21 plus 5, 9, minus 27, you get 0. Oh, therefore, x minus 3 is a factor. Now, since x minus 3 is the factor, the zeros of this polynomial is x equals to 3. The zeros of this polynomial is x equals to 3. Understand? That is the zeros of this polynomial. Clear? Over here, so if p and half is a factor, so the zero of this polynomial is x equals to half. Over here, so just now, you look over here, what are the zeros of this polynomial? The zeros of this polynomial will be x equals to 3 and x equals to 2, because the remainder is 0. Remainder 0, that becomes the zeros of the polynomial. Clear with this? So over here, p negative 1 is not 0, so x plus 1 is not a factor. But we know the remainder is negative 6. So there is no zeros for this polynomial. Why? Because there is not a factor. It must be factor, then only zeros exist. If it's not a factor, zeros does not exist. Simple as that. Easy? Can? So from here, let's just look at this one example here. They tell me 2x plus 1 is a factor of this polynomial. So p negative half, 2 negative half power of 3 plus p negative half square minus 5 equals to 0. Because p negative half must equals to 0. The remainder must be 0. So here I get 2 negative 1 over 8 minus p over 2 minus 5 equals to 0. So from there, I think you get negative 1 over 4 minus with p over 2 minus 5 equals to 0 times everything by 4. Negative 1 minus 2p minus 20 equals to 0. Shift over, so you get negative 2, p equals to 21, p equals to 21 over negative 2. Done there. Oh, sorry, my calculation error, is it? Oh, here is 1 over 4. Then, yeah, correct. Okay, so p equals to negative 21, I guess. Negative 1, here will become positive. Okay, positive. So p is 21. I hope that is clear for everybody. Okay, p is 21 over there. So done. Okay, can try one more maybe. X minus 4 is exactly divisible. Exactly divisible means there is no remainder. Okay, can divide exactly means there is no remainder. So you know that the x equals to 4. P4 must equals to 0, which equals to 4 cubed minus 13 times 4 plus k. So 64 minus 12 there, 62 plus k. Is it 62 then? 12. Sorry, 52. My mistake. So k here equals to negative 12. Done. That's it. Clear, right? Easy, right? Okay, quite easy. Now this one here, they say x minus 1 has a factor of x minus 1 and give a remainder of 50 when divided by x minus 3. So P1 equals to 0, P3 equals to 50. Substitute the value, get your two equation. Your first equation is a plus b equals to negative 10. When you substitute P1 inside, P3 there, you get 3a plus b equals to negative 4. Solve simultaneously, you will get the answer over there. Simple as that. Any problem until here so far? Can? Okay, so you can see that these are the balance questions over here. I mean, what examples over here which you can actually get the answer. Now, let's see this one now here. Over here, they tell you given that expression 3x cubed plus ax squared plus bx minus 12 is exactly divisible by x squared plus 2x minus 3. So if it's exactly divisible, so you can factorize this or not? I think I can. Okay, 3 and basically 3 and 1, yep. Okay, 3 and 1. Here will be positive, here will be negative. So from here I know P1 is going to be 0, P negative 3 also is going to be 0. I know this lah. Okay, so for me to find the A and B, I can substitute inside. I can substitute this. I can get 3, 1 cube plus A plus B minus 12 equals to 0. So A plus B is going to be negative 12, 3 minus 12 then negative 9. So equals to 9 there. First equation over here. Okay. The second equation there, you're going to get negative 27. Negative 27, negative 81. Plus with 9a minus with 3b minus 12 equals to 0. So 9a minus 3b, 3 there, 103 I guess. Yes or not? Negative 8, negative 27, 9 minus 3b there. So negative 81 there. Negative 81, let me just calculate this. Negative 27 times 3 there, negative 81. Negative 81, so here is going to become 393. Yes, right? So equals to 93 here. Okay, there's a typo over here. I think it should be 93 here. Okay, now from there you solve these two equations simultaneously, and from there you will get your final answer. Okay, your A and B answer will be given to you. Okay, this is one way. After that, they tell you that factorize the expression completely. Okay, now understand this thing here. This is a polynomial px. Okay, and the first the quotient there is 2x, no, the divisor there is x squared plus 2x minus 3, which does not give any remainder. But this is a quadratic, so you have to times what some more to get a cubic. So you have to times with a linear equation. I have to times some more with a linear equation. So from here I know that this is x minus 1, x plus 3, and ax plus b. And you know the polynomial here is going to be 3x cubed plus ax squared plus bx minus 12. Okay, so well, we know the a and b already, so we can substitute. So let's say I get here 3x cubed plus 10x squared minus x minus 12. Now for me to get the a and b over here, it's not that hard. It's quite easy actually. Okay, you just need to expand this thing again. So if I expand this thing out, I'm going to get ax cubed plus bx squared 2ax squared plus 2bx minus 3ax minus 3b. So ax cubed equals to 3x cubed. Therefore, a equals to 3. I compare x cubed with x cubed. And then I'm going to compare the next one there. Oh, 10x squared with x squared, x squared. That's all. So b plus 2a. b plus 2a must give me 10. I know a is 3, so b equals to 4 there. 10 minus 6 there is 4. Understand? And then you compare, you even can compare x with x, or you can even compare the last one there, number with number. Negative 3b equals to negative 12, which you get 4 there. So always people will compare the first one with the first one, and the last number with the number there, to get the answer faster lah. To get the answer faster, that's all. Not must, but to get the answer faster, we just compare that way. Can you understand that? Clear? Okay. Now, why here must be linear? Because here is a cubic. This is a quadratic. So quadratic times with linear will give me a cubic. Okay. Or you can go and do long division between this and this. You can divide this, take the polynomial, divide by the divisor. You also will get this. Can, but more longer. That's all. Understand? More longer. That's all. Can you all understand until here? Clear? So if you really look over here, that's it only for chapter 6 actually. There are a few examples over here for you all to try. Okay, once you finish these examples, then maybe I will be able to help you for the next lesson. Monday, maybe we can do a lot more questions lah. Okay, which part you don't understand, Hatta? Can I know? You don't understand how to compare x 3x cubed with ax cubed. So a equals to 3. Okay, x cubed I compare with x cubed. Okay, then 10x square I compare with bx square plus 2ax square. Okay, negative x I compare with 2bx, negative 12 I compare with negative 3b. Can you understand until there, Hatta? B, okay, I just repeated b just now. Okay, again, this is a quadratic equation. So a quadratic equation, you times with a linear equation, you will get a cubic equation. The cubic is given to you. The quadratic also is given to you. And you know that you can factorize this completely. And they tell me to get this ax plus b. How to get the ax plus b? Oh, I know this is quadratic, so here must be linear lah. Okay. From there, I expand out the thing. When I expand out the thing, I will get this equation here, the one you color. Then you compare x cubed with x cubed, x square with x square, color with purple color with purple color, no x with no x. But normally people will compare the first one first to get the A, then the second one to get the B. So from there you already get A and B, ma. So you already factorize the thing completely already. Can you understand that? If I ask you what are the zeros over here will be x equals to negative 3, x equals to 1, and x equals to negative 4 over 3. I hope this is clear for you, Hatta, right now. Okay. So, yeah, I hope everybody is clear with this and can do this lah. Okay.
Sir,
Yeah, say.
sorry for asking, but
It's okay.
how you get the quadratic equation?
The quadratic equation was given to you there at the top, x squared plus 2x minus 3,
Oh,
right?
okay, okay.
Because they already tell you is exactly divisible by this. So, of course, the quadratic equation is already there. Understand? Uh, okay, I hope that is clear.
Okay,
Okay,
thank you, sir.
cool. Don't worry, you try examples, then you will be able to see more better lah. Okay, so I will expect you to start doing the tutorial and also these questions over here. Okay, try first. And next lesson we will do more questions together. Okay, we will do more questions together. But the main idea is this all only. That's all. Okay, that's all only. So the next chapter is partial fraction. The partial fraction after this we will go in lah. Okay, but until remainder theorem you all should know already lah. Any problem until zeros there? Okay, until zeros you all should know. Okay, so I hope until here you all are okay. You all can start doing this part first. Everybody okay until here? Okay, good. If all no problem until here, I will try to set up a short quiz and then send to you all in the group for you all to perform. Maybe next week lah. Okay, maybe by next week. But today I will expect you all to take note for this, understand, and try to attempt the questions until here first. Okay, please attempt the questions until page 21 and also inside your your tutorial book. Okay, so with that I stop here today. Okay, I don't want to go into the partial fraction there first. Okay, and next week we will start with more examples and carry on with partial fraction on Monday. Okay, with that, thank you class. See you all next lesson.
Thank you,
Okay.
sir.
Okay.
Thank you,
Cool.
sir.
Okay. Thank you.
Thank you, sir.
Thank you.
So
Okay. Thank you.
Thank you, sir.
Yep. Thank you, everyone. Okay. Bye bye, everyone.